right, let's take a look at a few things. Why can we not divide by zero? I mean, your teachers always said, oh, you can't have zero in the denominator. Why can't you divide by zero? Does anybody have an idea? Well, let's figure it out. So let's first think, what does 6 divided by 2 mean? Well, it means you have 1, 2, 3, 4, 5, 6 things, and you want to put them in groups of what? 2. So there's a group, there's a group, there's a group. We have 3 groups. Division is saying put them in groups of. The top is telling you how many you have. The bottom is saying put them in groups of. So let's say that we have 1, 2, 3, 4. Let's put it in groups of nothing. Wait, can you really put something in groups of nothing? Does it make sense? No. Now you could have 4, like we have above, put them in groups of a half. And that's why if you divide by a half, like, oh, you only need half. Half to make a group, 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 half. That's why this answer is 8. That's why 4 divided by a half is 8. 4 divided by 0, you can't do it. It makes no sense to put things in groups of nothing. Really, this would be what? It would sort of be Mr. Infinity, would be the idea of what it approaches. But that's for much later on in your math life. So let's look at a situation like this where we want to simplify an expression. So we have n plus 3 over n plus times, n minus 1, the quantity, divided by the quantity n minus 1. Well, if we plug an n in there, let's say we plug in 7, you'll notice that this would be 6 and that would be 6. This guy is going to simplify to simply n plus 3. Now, if I had to plug 6 in, would you rather plug it in here or just go, oh, 6 plus 3 is 9? I guarantee you the answer to that thing, if you plug in 6, is going to be 9. It has to be. Okay? It has to be. Let's erase this. Oops. Well, didn't mean to erase that much. So this simplifies, as we said, to n plus 3. However, there was a restriction at the very beginning. What would create a problem if n were what value? Well, if n were 1, 1 minus 1 is 0, and you would get a 0 down here. You can't let n be 1. Okay? You can't let n be 1. So we need to make sure that right here, even though it crossed out and we don't notice it at this point because we're like, oh, n plus 3 is the same as that. You have to put the restriction. N can't be a 1. Because if you plug a 1 into the original equation, which was this, you would get an error. If you just say, oh, it simplifies to n plus 3, people aren't going to realize that n can't be 1 because it looks like, oh, I can plug 1 in here. 1 plus 3 is 4. So the answer to that equation would be 4. No, you have to remember the restrictions. So here, you and I notice n can't be a negative 4. Negative 4 would create a 0. But when you and I try to simplify this, we're like, hey, that and that cross out. This simplifies to simply n plus 5. Yes, it does. However, you must make the statement, it simplifies n plus 5, but n cannot be a negative 4. That cannot happen. So let's say we have this. You and I realize n can't be negative 6, and anybody that's messing with the problem, if they try to plug in negative 6, they're going to get an error. But when you and I simplify it, they might not see that. So we got to make sure in our final answer, we say if this is able to be simplified, that n can't be negative 6. Well, let's look. Let's factor the top. What multiplies together to give us 12 and yet adds to give us an 8? So we got to factor 1 and 12, 2 times 6, 3 times 4. Oh, 2 and 6. So the top will be an n plus 2 and n plus 6, all divided by an n plus 6. We're like, hey, that was great. They cross out. So this guy is nothing more than n plus 2. And boy, it's a lot easier to plug some value into n plus 2 than it is that big n squared plus 8n plus 12 all divided by n plus 6. So we would much rather plug in here. However, don't forget, you have to tell them You can plug anything in as long as you don't try to plug in this case, -6, because -6 will create an error. So we can't have that happen. Well, what about this guy? Well, we factor the top. 16, what multiplies together to give you 16, yet gives you a -6? Well, let's see. 16, 1 and 16, 2 and 8, 3 and nothing, 4 and 4. And what has a different 6? This guy. However, notice this is a plus 16. If it had been a minus 16, it would have worked. Nothing simplifies. This is already simplified. It's simplified all the way. Nobody's crossing out. Now, you and I do notice that n can't be -2. Okay? A lot of you will try to put an n minus 2, n plus 8, but a -2 and a positive 8, or excuse me, you would have put a +2 and a -8. But remember, those multiply give you -16, not positive. So don't fall for that. Let's look at this guy. Ooh, we're going to have to factor the top and the bottom. Well, let's see. For 10 and gives you a 7, I can see an n plus 2 and an n plus 5. In the bottom, for 6, what multiplies together to give me 6? 1 and 6, 2 and 3. Oh, it's a 2 and a 3. Now, is anybody going to cancel out here? Oh, look at that. Those go away. And this will simplify to an n plus 5 divided by an n plus 3. That's much easier to plug. Let's say n is 11. Would you rather plug 11 in here or 11 plus 5, 16 over 11 plus 3, 14? I would much rather plug into the n plus 5 over n plus 3. What did we forget to do? We forgot to tell the people you can plug it in here as long as n isn't what value. Well, a -2 here would have created a 0 in the denominator, and we can't have that. So we have to make sure we put what the restriction is. We're great at simplifying these, but we forget to put the restriction, and you must put the restriction. That's lesson 2.6 in Trig for you.